Hi, this is Abdul Bhartia, and welcome to a special edition of Red Hat Summit. And today we have with us Brian Gerkey, CEO of Open Robotics. First of all, Brian, I was supposed to see you in person at the summit, but we have to do it virtually because of this crisis. But thanks for your time, and we're going to talk a lot about what work you're doing there. So let's start with, tell us a bit about what is Open Robotics all about?
Open Robotics is a company where we're dedicated to producing and supporting open source software for the whole robotics industry. So what we do is lead an open source community that develops software that's used to program and simulate robots.
So when you say a whole industry, because when you look at robotics, it's a complicated industry. You look at Boston Dynamics, they make robots, but when you look at robotics, it's like a lot of automation is done there. So we are looking at consumer, we are looking at enterprise, we are looking at industrial. So which robotics are we talking about here?
Robotics, indeed, it's a vast industry, and continually to my surprise, the software that we've built over the last decade together with our global community has been applied to pretty much every robotics application you can imagine. We originally developed ROS, the robot operating system, to run on large research robots that are used in labs. These were mobile robots with arms that were not intended to be final applications. They were scientific instruments, and that's how we originally targeted the software. But since then, that same software in different configurations and different forms has been used in everything from logistics robots that are moving material around in warehouses to robot arms that are doing advanced part handling, to autonomous cars, to drones, to boats, to submarines. Pretty much everything that you can imagine, people have found a use in the open source software that we've been building.
So Open Robotics deals with the software side or the brain side of the robots, not on the exoskeleton or the hardware side. Is that correct?
That's right. We sometimes dabble in the silicon, you could say. So we occasionally do some work in open source hardware. So some actuators, motor controllers, sensors like stereo cameras. And we maintain a line of platforms called the TurtleBot. These are low-cost, entry-level robots that are meant for use in education and prototyping. But that, largely speaking, we focus on the software.
Tell us, what are you doing here at the Red Hat Summit? What is your involvement there?
Well, the team at Red Hat approached us last year, I suppose, to say that they had an interest in doing a documentary film about the open source software ecosystem in robotics. And that became a film that they're going to release, I think, later this month, called How to Start a Robot Revolution. And they came to us and pitched the idea of interviewing myself, some of my colleagues, some of my former colleagues who have been involved in this overall effort, and it seemed like a good idea.
I want to understand your own background, when did you get interested in robotics and why?
So when I was an undergrad studying computer engineering at Tulane University in the 90s, there was a new professor who joined the department, and he brought robots with him and put together a robot lab. So maybe partway through undergrad, it came time to find someone to do some exploratory research with, and robots just seemed way cooler than databases or web applications. Although in retrospect, maybe there was more financial return in databases and web applications. But what are you going to do? And the robots were just so engaging that it's hard to explain. But if you're used to doing software development, it's very different when you do software development and when you get it right, something actually physically moves in the world and you get the right answer through a physical response. So that got me really engaged as an undergrad, and then when it came time to graduate, I decided, based on that experience, to go on to grad school and keep studying robots, and I've been with it ever since.
And when did you get what kind of exposure you got to open source, and then you merge these two loves of yours together?
My first experience with open source software was also in undergrad. I went into college, unlike kids today who come into college already knowing a whole lot about programming. I knew nothing. I just knew that computers were interesting. And I got to college and we started using Unix in the lab. And then someone who lived in my dorm came to me and told me about this thing called Linux. And this would have been 94, 95. And he had this 3.5-inch floppy that we could boot from and then do a network install of Slackware Linux version 1 dot something onto my old 486 computer. And it took like a day and a half to get it installed, and then it took another week to get the windowing system up so I could actually have a graphical interface. But it was totally worth it. And then I had completely open source software on my machine in my dorm room, and I never looked back.
If you look at robotics in general, um, first, how much it relies or uses open source, and how much collaboration is going on within the robotics industry, both hardware side and software side?
The robotics industry relies tremendously on open source software, and that's in part just because it's a part of the technology industry, and every part of the technology industry these days relies to a great extent on open source infrastructure software, from operating systems like Linux to the databases and the web servers and all the basic components that hook everything together. We're all using open source software all the time. Every major company does. Robotics then in particular uses that central infrastructure and then also uses a lot of domain specific software. That includes things that we've built like ROS, and Gazebo is a robotics simulator that we develop. But it also relies on other domain specific open source packages like OpenCV, which is used for computer vision processing, or PCL, which does point cloud processing. And I think what has happened over the last 10 years or so is that community has really established critical mass around the maintenance and application of all these different libraries to particular robotics applications. And so then the result has been that we've got quite a lot of collaboration, a surprising amount of collaboration in what is frankly an increasingly competitive industry. You have companies who are building very similar products in, for example, mobile robots in warehouses and factories, and they are to some extent, to a surprising extent, working with each other by pushing changes upstream into the common platform that they all build on.
If you can just talk a bit about the community where companies like Red Hat are also involved, some hardware companies are also involved, and then there are a lot of scientists, engineers, or enthusiasts are involved.
The ROS project has been a very diverse community effort from the really early days. I remember when we started working on it, there was a company called Willow Garage where some of us worked, and we were developing the early versions of ROS. And we got connected with, here in the Bay Area, there was a group called the Homebrew Robotics Club. And this is a group of hobbyists. They named themselves after the Homebrew Computer Club from a long time ago. And they are enthusiasts. They get together, they build robots in their houses, in their basements, in their garages, and they come together and show off their latest projects to each other at regular meetings. And they found out what we were doing with ROS, and they got on board really quickly. So we had these people who had no formal training at all in robotics or necessarily even engineering, but had a deep interest in the field. And they were some of our earliest, let's say, non-traditional users of the software. And that helped tremendously in our deciding how to develop the system, because we really want to make it as easy as possible for people to come into the field. I think what holds us back as a field is it's a lack of good ideas for what robots can do. It's not a lack of people who know how to use robots. It's a lack of knowing where are the best applications. Where can I put a robot to good use in the world? And to that end, I think it's incumbent on us to make it as easy as possible for those hobbyists, those enthusiasts, those students to get in and come in with their ideas. And so that's what we're doing, is trying to lay the framework to make it as easy as possible for them to come in. Along the way, we also get a large ecosystem of companies, because those people come in, they start companies, and so now we've got a really vibrant ecosystem of hardware and software companies who are all relying on and contributing to, in some way, this open source commons that we've built.
If you go back to the main point of open source and robotics, And you are aware of the industry side of it. You are also interested in the community side of it. You are also aware of the research side of it. What are some of the basic challenges that you see that are there, which the community is working on, or you think that we should be addressing?
So I think one of the probably the biggest challenge that any open source community faces, and we do as well, is making sure that we're getting the contributions that we need from the whole community. And it's one of the truisms of doing open source software is you're going to write it and give it away, and only a tiny fraction of the people who use it are going to actually even give comments back on how it works, right? Most people take the software, they use it, and they don't say anything about it, much less do they come back in and fix bugs and push in new features. So I think the biggest challenge we've had, which is similar to all open source communities, is just making it as easy as possible and encouraging people to make those contributions, because that's what keeps the whole community going. I think we've done quite well with that, but it takes a lot of effort. You have to spend a lot of time engaging with the community. We host an annual developers conference, which has localized versions in other countries to bring the community together to get them connected. So that's on the general side of just challenges of running an open source community. More specific to robotics, I think that the bigger challenges these days are around, you mentioned earlier, real-time control, and that's one, or real-time operating systems. That's one component of what I'll call getting into mission-critical systems. And so there's a lot of interest in using the kinds of software that we develop in systems like airplanes, cars, rovers, and those kinds of aerospace and automotive applications. You have to have a very high degree of confidence that the system is going to do what it promises to do, and it's going to do it incredibly reliably. And to that end, we need to have a very good way of verifying that the systems we're building are fit for that purpose. And so part of that is I believe, in making all of the software open to inspection for everyone so that everybody can understand how it's designed, how it's implemented, and know how it was tested. And then on top of that, we spend a lot of effort at Open Robotics in developing software simulation systems. And those allow you to then take that system and test it in ways that you will never be able to test it in reality. That is that's a testing feature that is especially important for systems like autonomous vehicles, where it's pretty well understood that we're never going to drive all the physical miles we need to encounter all the situations we need to ensure that a given autonomous driving or even just automated driver assistance system can handle what we want it to handle.
Awesome. Thank you, Brian, for taking time out of your schedule and talking to me today. And as I said, I would really look forward to seeing you in person at some physical event whenever that happens. Thank you once again.
Let's do it next time. Thanks.